Submarines are some of the most fascinating machines ever built. They can disappear beneath the ocean's surface, travel quietly through the deep, and then rise back up whenever they need to. But how does a massive metal vessel dive and surface in water so smoothly? Let's explore the amazing science and engineering behind submarines. A submarine's ability to move up and down in water is all about controlling its buoyancy, the force that makes objects float or sink. To understand this, think of a simple example. When you drop a rock in water, it sinks because it's denser than water, but a beach ball floats because it's filled with air, which makes it less dense. A submarine, surprisingly, can be both. It can change its density whenever it wants to. The key lies in special tanks built inside the submarine called ballast tanks. These tanks can be filled with either air or water, depending on whether the submarine needs to float or dive. When the submarine is on the surface, the ballast tanks are filled with air, which keeps it lighter and more buoyant, allowing it to float. But when it needs to dive, valves open and let seawater flow into the ballast tanks. As water fills the tanks, air is pushed out through vents, increasing the submarine's overall density. Once it becomes denser than the surrounding water, the submarine sinks. When it's time to surface again, the process reverses. Compressed air stored in high-pressure tanks is blown into the ballast tanks, forcing the water out through valves at the bottom. This reduces the submarine's density, making it lighter than the water around it. And it begins to rise back to the surface. It's an elegant balance between water, air, and pressure, all controlled by the crew with incredible precision. But staying underwater isn't just about going up and down. Submarines need to control their depth carefully to remain stable. For fine adjustments, they use smaller tanks called trim tanks, located at the front and rear. By shifting small amounts of water between these tanks, the crew can level the submarine perfectly or tilt it slightly to move up or down. Inside the submarine, maintaining air pressure and oxygen levels is equally important. When submerged for long periods, submarines use systems that recycle air, removing carbon dioxide and adding fresh oxygen. They also manage temperature and humidity to keep conditions safe and comfortable for the crew. For movement, submarines rely on powerful propellers or pump jets driven by engines, often nuclear or diesel-electric. These engines don't just move the vessel forward, but also generate electricity for lighting, navigation, and life support systems. Modern nuclear submarines can stay underwater for months, as they don't need to surface to refuel. Their reactors produce energy continuously. The design of a submarine's hull also helps it handle extreme pressure. The deeper a submarine goes, the greater the pressure from the surrounding water. The hull is shaped like a cylinder, with strong steel or titanium walls that evenly distribute pressure, allowing submarines to dive hundreds of meters below the surface safely. Submarines also use periscopes and sonar to navigate while underwater. A periscope lets the crew see above the water when close to the surface, while sonar sends sound waves through the water to detect obstacles, other ships, or even the ocean floor. This technology helps them see in the dark depths where light can't reach. So, the next time you think of a submarine silently gliding through the ocean, remember, it's not just a vessel. It's a brilliant blend of physics and engineering, balancing forces, air, and pressure to conquer the underwater world. If you love learning how amazing machines work, don't forget to subscribe to my channel How Things Work and comment the next topic you want to learn.